Hi there, I'm Hao, and this is just another video of me solving random code problem. So we have to invert the binary tree. We are given the root of the binary tree, and we have to invert the tree and return the root. So what does invert mean? Inverting mean so if we just look at the smallest subtree, right, which is this one, right? We see that the parent stay the same, and then the left and the right children are swapped, right? So we can tell that inverting means swapping the left and the right children, right? We see that this left subtree goes to the right, right? And this right subtree goes to the left, right? And similarly, the left subtree here goes to the right, right? And the right subtree here goes to the left, right? So on and so forth. Right, so how can we solve this? So let's say we have a tree like this, 4, 2, 7, 1, 3, 6, and then 9, right? We can set, so the root, the parent stay the same, so we can swap the pointer, right, between them, right? So let's say this is the left, and this is the right pointer, right? And we can swap them, right? This become a right, and this become the left, right? So root the left become root dot right, and root dot right equal to the root dot left, right? So we can do root dot left, right, equal to the inverse of root dot right, right, and root dot right equal to the inverse of root dot left, right? We can just uh swap the pointer. Uh, so this become right, this become left, right? Similarly over here, right? This become right, this become left, right, left, right? And if it is a leaf node, we just return, right? Okay, so this will almost work because um, by the time we finish executing this line of code, right, root dot left is no longer the original root dot left because this is already inverted, right? So we need to store the root dot left, the reference to the root dot left before we calling the recursion method, right? And we can pass in the original root dot left here, not the inverted root dot left. Right? So using this way, we can invert the tree. So what is our base case? Our base case is when we reach a leaf node, right? Which means the node doesn't have a left or a right children, and we just return back up. Okay. All right. So let's walk through this. So our term will be the root dot left, right? Which is this part right here, and then root dot left equal to the inverse of root dot right. Okay. So let me just delete this. So root dot left become the inverse of root dot right. So 7, 7, 6, 9, right? And now this is our current root, right? So root dot left equal to the inverse of root dot right. So this become 9, right? And now our root is 9. So root dot left equal to the inverse of root dot right, right? But however, this is already a leaf node, right? So we return back up to 7, right? Similarly, when we finish the root left, we can jump to the root right. The root right equal to the invert of the term, right? So remember the temp earlier is the 6, right? Of the root dot left. The root is 7, root dot left is 6. We store that, right? So we can do 6 here, and we can continue. This is our root, right? This is a leaf node, so we return back up, right? Similarly, we finish in the left subtree of 4, right? Equals to root dot right, and now we are going to the root dot right, right here, which is 2, 1, 3, right? So now this is our root, right? Root dot left equal to the invert of root dot right. So we copy the 1 here, right? It is our temp. Root dot left is equal to root dot right, right? So now this is our root. So we got it as a leaf node. We return back up, and we finish with the left side. Now we go to the right side. Root dot right equal to the invert of temp. What is temp? Temp is here, right? Now we are at 1 is our root. It is a leaf node, right? So we return back up, right? And we are done. And then we can return the root. Okay, so let's code this up. So if the root is null, then we can return null. Right? We need to keep track of the left subtree, right? So root of left equal to the invert root right, and then root of right equal to the invert root or temp. You can return the root. So after line 16, the root of left is no longer the root of left, but the root of left is the invert version of the root of right, right? So that's why we need to use the old root of left here, which we store in our temp variable. So let's try this. Accept it. And thank you for watching.